Hi, welcome to this tutorial. This is Teacher Raya from Elimohab's Maths. We're going to solve question 5 from NECTA 2015 Form 4 math paper. So this question is about geometry. The first part is to do with similarity and the second part is just general knowledge of angles. So let's start. Okay, so we are told for part A, two triangles are similar. A side of one triangle is 10 centimeters long, while the length of the other corresponding side is 18 centimeters long. If the given sides are the bases of the triangles and the area of the smaller triangle is 40 centimeters squared, find the area and the height of the larger triangle. So we need to find the area and the height of the larger triangle. Okay, so let's just draw those up here. So we got a smaller triangle. Then we have a larger triangle. These triangles are similar. This one, 10 centimeters, and this one is 18 centimeters. We are told they are the bases of the triangles. So what does that mean if they are similar? It means the ratio of their length is always the same, corresponding length. We have area for this one, 40 centimeters squared. We need to find area for this one, and then we need to find height for this one. Okay, so first thing you need to do is find a length scale factor, which is going to be equal to 18 over 10, which is 9 over 5. And why do I need length scale factor? Well, there's no other way of me finding the area unless I find out what the area scale factor is. So I'm going to use the similarity knowledge to find area of the larger triangle. Okay, so area scale factor then is equal to length scale factor squared. Okay, so area scale factor is going to be equal, what's the length scale factor squared? Well, it's going to be 9 over 5 squared, which is going to be equal to 81 over 25. So that's your area scale factor. What else do we know about similarity? Well, if you take the area of the larger triangle, divide by the area of the smaller triangle, you will get area scale factor. So this means then, if you want to find area of the larger triangle, all you have to do is use the area scale factor times the area of the small triangle, which is going to be equal to 81 over 25 times the area of the small triangle, which is 40. So if you calculate this, then you get area of the larger triangle equals to 129.6 centimeters squared. So now we need to find the height of the larger triangle. So we know area is equal to base times height divided by 2. So we're after this one. We need to get rid of this one by multiplying by 2 and get rid of the b by dividing this side with b. So height is going to be 2 times area, the larger triangle of course, divided by base of the larger triangle. So this is going to give you height equals to 2 times, we know the area is 129.6, divided by the base, which is 18, and this will give you 14.4 centimeters. So that is part A completed. B then. So we're told in the figure below, CB, this side is equal to this side BD is equal to the side DA. And angle ACD is equal to X. Show that the angle ADE is equal to 3X. So that's the angle here. We need to show this is 3X. Then for part II, we need to find calculate the measure of the angle CDA, so is this big one here, if x is equal to 39 degrees. Okay, so let's start with I then. So ADE, let's look at the our diagram, I can see straight away we have two isosceles triangles. What does that mean? Well, I'm just going to make my life easy and just do these angles. I know this angle is going to be x because triangle BCD is an isosceles triangle. So angle BDC is equal to x because triangle BCD is an isosceles triangle. Okay, so that's that part. Now I can use another knowledge of triangles. This angle here, ABD, so angle ABD is going to be equal to this angle here plus this angle here. Why? Because the exterior angle of a triangle is equal to the sum of the opposite interior angles. So this angle, if I have something like this, if I have a triangle like this angle here is going to be equal to this angle plus this angle. So this one is called the exterior angle, and these two are the opposite interior angles. And that's why we say this one is 2x. So let's just write it down here. So angle ABD is equal to 2x because you add those two. And the reason is, make sure you make a note of it, exterior angle of a triangle is equal to the sum of the opposite interior angles. Now what else do I know? I know this angle is going to be 2x. So that's angle BAD. And what's the reason? Well, I have this angle triangle ABD as an isosceles triangle. So I'm going to say angle BAD is equal to 2x because triangle ABD is an isosceles triangle. Okay, so now I've got this angle that I'm after, but again I can see the triangle ACD as a separate triangle. So I can now say angle ADE is equal to 2x plus x. And what's the reason? It's exactly the same, because if you look at the triangle ACD, you can see this big triangle here. You can see this is the exterior angle, and these two are the interior angles, so they're the same. So for the same reason, you must write it down. So now we have shown angle ADE is equal to 3x. So for part II, we're told to find CDA, so is this big angle here, CDA, if x is 39. So if we know this is 3x, we can find what this angle is. So angle ADE is equal to 3 times 39, which is 117 degrees. So to find angle CDA, so angle CDA is going to be equal 180 degrees, take away 117 degrees, which is going to be 63 degrees. And what's the reason for that one? Remember, all these little reasons, they're worth a mark. So you must write them down. And the reason for that is angles in a straight line add up to 180 degrees. Because if you take this angle and that angle here, that will add up to 180 degrees. Thank you for watching and see you again.